Are you using source code control?
Me?
Yeah.
Oh, I'm a single programmer in a.
Ooh.
But
So
I
what's the
like
point?
what's the
Ooh, ooh, okay, just hold him. But how about back there? Why is it that you're not using source code control?
Oh, I'm just using by myself in the lab.
Okay, I know they're by myself. All right, good.
Not an excuse. Not
Okay.
an excuse.
Who's using Subversion? All right. Mercurial. Git. All right. Perforce. All right. Which one are you using that I didn't mention?
DFS.
DFS, yeah. Team Foundation. All right. Any other? Yeah. All right. Okay, so I guess I'm gonna start since nobody. So my name is Fabiola De la Cueva. People also call me Fab, as in fabulous and modest. There's emphasis on the modest side of things. We are based here in Austin, so that's why I got to present this presentation that I actually made for Dev Day. So it has already been presented in the UK and I think in Albuquerque and other places. So that's why they have the About the Session author. I'm the founder of a small consulting firm. It's called Delaport. We focus on working with teams and helping them figure out what are the software engineering processes that they should be using, best practices, training and implementation, software architectural design, hardware design consulting we also do. And even though we are a small firm, we do have customers worldwide. So and if you need references, we can provide references. As far as products, we have DQMH. Who here is using DQMH?
I have before.
Okay, we'll talk later then. And I guess for the rest, you're probably going to hear more about DQMH later. There's another presentation called Choosing a Framework that's going to be talking about that later. And we also have a lock-in amplifier for MyReal. And the DQMH won LabVIEW Tools Network Product of the Year of 2016. All right, so this is a true story. If you've seen me present before, you've already seen this cartoon. We called this third-party vendor. He was doing motion control for us. And we called him and said, the new version introduced a bug. And he said, that is impossible. I never add bugs to new releases. So I asked him, can you tell me what changed? No, I just changed what you asked me to change. Can you revert to the previous version? No, I only keep current code. So then I asked, what method of source code control you use? And his answer was, why would I use source code control if I am a single developer? My friend Steve Watts came up with this. Good programming practices have nothing to do with marital status. So this joke doesn't work in other languages, it works just in English. But just to give you another story, Luis here, he's the hardware side of Delaport. He also happens to be my husband. And one day he walks into the office and says, my LabVIEW project just got corrupted. And I'm like, oh, no problem, just go to the previous version of source code control and recover it. And he's like, well, there's that. I was not using source code control. And I was like, hey, how many hours have you been working on this project? And he's like, well, 5 or 6 hours. And I'm like, are you willing to throw 5 or 6 hours of your work into a trash can? So his answer was not, and then from then on he has been using source code control. And also I have authorization to tell this story, so there's different reasons to use it. So anytime you feel yourself answering, I'm not using source code control because I am a single developer, just remember my friend here. All right, so source code control is also known as version control system, source code management, or revision control system. So I'm using this vocabulary here because we tend to use within the LabVIEW community the source code control acronym, but once you go out into the general interwebs, that's not so much the term. So it's important to know this vocabulary if you want to do more research on your own. Every project, regardless of size, can benefit from source code control. So think about how many hours of your day you're willing to lose if your project gets corrupted. That's the example that I just gave you. Make this your trigger to decide whether or not to use source code control. Also, source code control provides for the single developer a big macro undo. You can go into a deep rabbit hole searching a new approach to something, and you don't have to worry about keeping track of that. You can then decide if you get nowhere to go back in time and go to the version that had the last useful code for you. And source code control commits without comments are like a movie script without a plot. So please, it's not just using source code control, it's actually writing a couple of comments of what was your state of mind when you made some changes. And Eli says this a lot, not using source code control tools is like playing with fire. And one more thing that I'm not putting here is also do not use source code control as a backup system. Sometimes when I go and work with teams, they're like, yes, we're using source code control, but it turns out they commit at the beginning of the project, and they commit when they deliver to the customers. So you go to their repositories, and there's just one huge commit. So they're using source code control as a backup system. There are better tools for that. Right? Okay. So what we're going to be discussing is centralized versus distributed source code control, branch merge versus code merge, and then the main idea of this presentation is LabVIEW compare and LabVIEW merge. So I'm going to also talk about how I personally believe that overuse of LabVIEW compare and LabVIEW merge is regularly an architecture smell. It is a cool tool to have, it is useful, but if you are abusing it, there's other things we need to discuss. And then we're also going to talk about how to handle LV crush, LV leaves, and classes. So what is source code control? Alan, you wanted to know what is source code control. So I think it's the most important technical asset for any software development team. And I'm not exaggerating with this. When I started doing consulting, I started back in 2006. I didn't know anything about source code control. And as soon as I learned about it, I'm not working with a team if they refuse to use source code control. That's how important it is to me. It keeps track of every modification done to the code. Developers can travel back in time. That to me is the most important feature. You can see what the code looked like in the past, revert changes, or determine when a bug was introduced. A recent example I have, a customer called me and said, some along the ways we dropped this feature. So I went to the VI that had the feature, went to the log of all the commits, and I found out that in 2015 in October, the customer had requested to drop that feature. There was a comment that said that and pointed to a JIRA case. I went to the JIRA case, I had the whole story. I just sent him back the information saying, this was your thought process in 2015. So it's okay to change your mind, but here's you from the back, from the past, reminding you why you wanted to do this. So we can definitely revive it, and that's a nice thing. I can go back and see how the code was done and just recover that code. It's not lost in time. And this is another big important reason. I swear to God, I've seen this. Best one, better one, good one, greatest ever 1.0, greatest ever 2.0. And then they start they get so excited that they start doing the whole enchilada, and then they start adding condiments to it. So the whole enchilada, this is really, this time for real, swear, the whole enchilada, beans, rice, and a margarita. And I've seen all of this.
She's not making this up, by the way.
Yeah. These are, no customers were harmed in the process of gathering these names, but
That's how it should have been.
they almost were. They almost.
These are multi-million-dollar companies.
Yeah,
These examples are.
Yes. So who does this? Of course, nobody's going to own for it now, right?
The sad part is that people will stop doing this with code, but they keep doing it with their project documents.
Oh yeah, that's true. They stop doing it with code. And this is something that Luis on the hardware side, he actually started using source code control to keep track of new parts, schematics, and other documentation collateral that we have for projects. Okay, so centralized source code control. You have a central copy of the project, and it is typically a server, or it could be a map drive. Just don't put it on the same computer you're working on, please. Developers commit their changes to that central location. So you have, and what you call each one of the stations where the different developers are working, it's a working copy. Examples are CVS, SVM, Perforce. I think Team Foundation Services is also centralized. The process is, you step out, the step one is you check out your working copy. So you have a checkout. And then all of the rest of the team members do their own checkout. Okay, that's the regular term. Use that to get your section of the code that you're going to be working on. The step two, The developer makes changes and then commits them. And then the way the rest of the team gets it is by update. All right? If two developers make a change, whoever gets there second needs to update first and then resolve any conflicts. What do I mean by that? The first guy commits, the second guy commits, but then you cannot keep going. You have to update, deal with conflicts, and now you're ready to commit. And this is one of the things that I don't like about centralized. I feel like centralized source code control is not respectful of my workflow because I have to deal with those conflicts right there or it won't let me commit. Where I'm going to show you in a little bit, one of the reasons why I like distributed source code control is that it's more respectful of my workflow. I can take a peek and see what the other developer did, but I'm not forced to deal with conflicts at that moment. So I can wait until I am in the state of mind to deal with them. All right, so some disadvantages. Developer requires a connection to the repository in order to commit, update, and even read the log. So that story that I shared earlier about being able to figure out what happened would not work if I'm at the customer's place and we're not connected to the server. When committing, they need to address conflicts right then and there. Developers do not commit as often in fear of conflicts or breaking others' code. And this is one of the challenges when I work with teams, because you do want people to commit often. And if you want to use it as a macro undo, you cannot afford having a commit every week, right, if you're working daily on the code. Now, this is a personal comment. Repositories tend to get too large because developers can only check out the section they're working on. So what I have seen out there at companies is maybe they have a single SVN repository for all the projects in the company. So that means that if somebody messes up that repository, they take all the projects down with them. So I totally do not recommend doing that. Okay?
The scenario where you're talking about developers not committing, is that, I guess what I've seen for the centralized is you typically will branch your own dev, so you're not screwing up somebody's, and then at some point in time you'll merge back in. Are you still saying even with that type of development flow, that still
happens because they don't want to get into that situation where dealing with the merge, or they put it off until too later.
Okay.
Which I have not seen that as much with distributed, because distributed the branch merging is so transparent, it doesn't really require much. Even if you're not having an actual branch, if you have two people working, it just happens. Where within SVN, if you would have your development branch, you would have to then have a special commit to do the right-click branch, and that extra effort makes it where people would not do it. Yeah. All right. So distributed source code control. The central copy of the project is in a repository, is typically a server. And then each developer has a clone of the entire repository. Now, developers commit their changes to a local repository in their computer. And then when they're ready, then they can push to everyone else. So what this means is, in the case, for example, of consultants, where we're not always having access to that internet connection, that means that I can be working at a customer site and do a lot of commits to my local copy. And then when I get back to home base, I push to the repository, right? And that's something that with SVN you cannot do. If you're not connected, you have no access to all the nodes and stuff like that. So examples would be Git and Mercurial. So the way this flow works is you clone your repository. So each one of the developers has it. The other advantage of this means that if you ever have to recreate your repository, you can do it from any one of the clones. When in SVN, because they might have checked out only a section of the files, you might be in the situation where you cannot recreate it. Now, this still means that you should have backups of your repository regardless, but it is a lot easier to retrieve a repository from a clone than it is from an SVN or Perforce checkout, if they didn't check out the whole thing. If they check out the whole thing, you might be able to recover. All right, so developer makes changes and commits as many times as needed to their local repository. So what we have in here is Joe here is making commit after commit after commit, and then when they're ready, they push to the central repository. and then the way the rest of the team gets it is they pull. And this is where I say that distributed is a little bit more respectful of your workflow, because you don't have to update at that moment. When you're ready, then you update. So you pull and then you update. If two developers make changes, whoever gets second pulls and can choose to either update, resolve any conflicts, and push when convenient. But they are in control when they do that decision. So we have the two developers pushing, they pull, you get the same warning that says that you're not ready, you deal with conflicts, and then when you're ready, you push back. All right, so I'm going to show you these. Oh, another thing, branch merge versus code merge. The branch merge is when the files of a project have been modified in two separate branches, and then they get combined into a single branch. Different developers can be working on different branches. These may or may not involve merging code, because they might be working in separate branches but separate VIs. So as long as they don't touch the same VI, then you don't have to merge the VI. Code merge is when the same code file has been modified in two separate locations, and then you get to combine them into one. All right, any questions about this? No? Okay. All right, so start. What we're going to do is, this is a little bit a longer video that shows the whole workflow, just because I want you to see the whole thing about being able to peek into what's going on. So we're going to have two computers. So the first computer is Fabiola's computer, is the blue computer. She's going to Tortoise, she's cloning. We're going to call this directory Fabiola. She does the cloning, shows the details, and gets all the information there. Then we go to the gray computer, Jane. So Jane is also going to clone. She's going to choose to put it in the folder Jane. She's going to clone. And then notice how as soon as the cloning is done, the folder just showed up. What we're going to do is, of course, because it's DQMH, we created a DQMH project. And then Fabiola here is going to do two commits. One is not on the video, and the second one is committing the initial DQMH project. So she's adding all the files that she just created, adds, puts a comment, commits. Now she has not pushed yet, so now she goes to HG Workbench, and then from there you can see that there are two commits there that say on the face that they're on draft. And as soon as she's done pushing, they're going to go from draft to public. Okay? So now Jane can go and say, okay, I'm going to pull. So she pulls, and she can see that Fabiola made two commits. Now the nice thing here is that Jane can actually travel in time through Fabiola's setup by updating into the first commit. So that first commit was just adding an HG ignore file that just what it does, it says do not put in source code control aliases and .lb/lps files. You don't need them in source code control. And then she updates to the next version, and now she has a full LabVIEW folder there with the DQMH project. Okay? So that allows to see if the other developer did like 5 or 10 commits, she can explore all those commits step by step and go through the process. So Jane here just added a new DQMH module. So she's put in the comments, and then she's saying, please add it to the project in the next commit. Now, what the arrangement they have here is that Fabiola owns the project. So Jane is not committing the project to avoid conflicts with projects. We're going to talk about that later. So she does the commit. Fabiola now does the pull. And then when she does the pull, she's going to see that Jane created a new DQMH module, but it was not added to the project. So she's going to update there, and then open the project, and she knows that there are two things that she's going to, you see there that the folder, Jane's folder, is not there. As soon as we do update, it's going to show up as my other DQMH module. There it is. So now I can go to the project, and on the project say, I need to add Jane's module as the new DQMH module, and I also know that DQMH always has a tester, so I'm going to add the tester as well. So we go and add the tester. And now Fabiola can save the project and say, done Jane, I added your module to the project. Okay? Now, she pushes, and now we're going to see what happens with several changes later. Both Fabiola and Jane are working at the same time, but Jane is not ready to merge. At this point, they decided to work on the same code. So Jane is pulling the changes. Jane has pending changes. You can see that she has a draft there, but she's choosing to update to Fabiola's version without committing her changes. She wants to take a peek and see what is it that Fabiola has been doing. So she can go and check. Let me open the code. I can see the document. It says the commit note says remove labels and change the button text. So Jen can go and open the code without having to worry at that point on dealing with her own pushes. Right? So she updates, and now she's updating to see what else Fabiola did. So she goes to the project, oh, there's a hello world, there it is, that's what she did. So now Jane can decide, I'm done taking a peek, I'm gonna go back to where I was. And then I'm gonna work directly where I was because Jane is in the zone with this populating table code. She wants to finish this part before merging with Fabiola's code. And it's until she's done that now she's gonna do a merge with local. This is what I mean by distributed source code control being more respectful of my workflow, because I didn't have to deal with an update and resolve conflicts right away. Okay?
Just do the peak.
Yeah. And then when she's done, you have the draft. Now you're ready to push, and I think that's it. Okay. Yeah, and then Fabiola just can go. She just has to do a pull because Fabiola stopped working. She's not doing anything else. She can see what Jane did there. She could go and take a peek and see what she was doing, but when she's done, she just updates, and now they're both at the same place. The other thing that I like about the distributed source code control tools is that graph, because I call it the subway. It really shows you where everyone in the team is at. Okay, questions?
Okay, so the one that I had a little bit earlier is when you were showing you can update without issue pretty much, because that's just updating your centralized, your local
Yeah.
central. But then you were also updating one at a time.
Mm-hmm.
Is that a requirement, or is that just kind of?
No, that was to show that you can travel in time, and
Okay.
you can.
But if you wanted to, you could pretty much take
You could
whatever
go to the
once,
top.
and it will do all.
Yeah,
at once.
and also for those teams, one of the things that I've realized with time is that tools can be awesome, but if the team doesn't follow them, it doesn't matter what great process I come up with. Okay, so there are certain teams that have been using Subversion for a long time, and maybe the rest of the team gets how Mercurial works, but there's one person in the team that just doesn't want to follow it. There are ways to configure Mercurial and Git, your client, your Tortoise Kit and your Tortoise Mercurial, to treat a commit as a commit push and to treat a pull as a pull update. So it combines both actions. To me, that is kind of like putting a big train in wheels, but if that allows the rest of the team to move on, maybe one day that person will catch up with the advantages and will be ready to remove the training wheels.
To an extent, doesn't just the ability that you're talking about of saying, okay, I can just keep I'm going to call it a branch just because that's the term I'm more familiar with, but Jane saying, okay, I'm going to look at your code and saying, I'm not going to deal with this just now. If you keep doing that, you're just creating further and further branches. So to me, it sounds like, and correct me if I'm wrong, that all you're doing is kicking the can further down the road rather than dealing with it when it's probably a more appropriate time where now instead of, let's say, 2 changes, we've waited 3 days and now we've got 20
and
changes.
that's definitely a team everything. It's just that, to me, is the opportunity of having that choice of saying, I know I need to deal with this, but there might be other things that I can do on the code to be ready for that merge. And I might not be ready. Where with SVN is like, sorry dude, you have to deal with it now if you want to commit. And people get discouraged about doing their commits because they don't want to deal with dealing with the conflicts. So then the problem you end up with having on SVN or centralized is people keep making the changes and not committing any of those intermediate steps because they're waiting to get to that nice spot where they can deal with it. And now they've lost all that individual macro. So, and again, this is not the way of using source code control, it's just a way. And it's a very personal opinion.
It seems, going to Aaron's point, it seems like that's a couple of hours useful thing as opposed to a couple of days,
Yes,
a couple
exactly.
of weeks useful thing.
Yeah.
I don't want to deal with that. I'm doing something right now. I don't want to deal with your change at this exact moment.
Yes.
give me a couple hours and then I can wrap my brain around whatever it is. She's not going to do that much work in that time.
Yeah, yeah, it is.
It's very prolific.
It is an hours thing, not a days thing.
So a couple of points. One is LabVIEW specific, and that is that revision control systems of this nature distributed, they work best with textual files because there's no way you can merge binary files.
Oh no, so we're gonna get to that. That's part of the presentation. So anyone else? No? Okay. I just wanted to kind of give this introduction because otherwise it's like, why are we even talking about this?
So just a very quick aside, Perforce does actually support distributed versus primary repository now.
Okay. All right.
So just as an FYI.
All right, I'm gonna go. I was not aware of that. So Aaron is saying that Perforce now supports the distributed mode. So I'm gonna go and read into that because I was not aware. So LabVIEW compare. LabVIEW compare.exe is equivalent to the compare VIs dialog box that you can find on tools compare VIs. Does anybody use this tool? All right. Do you use it often?
No.
All right. So it's only available on the LabVIEW Professional Development System. It works like those find the difference games that kids have, where you have two images that are very similar, and then you find out what the differences are. So one of the things that I like to tell people is, remember, is find the 5 differences, not where is Waldo, okay? So if you are trying to use LabVIEW compare with a huge the VI, right? And when I say the VI, I mean this VI that's like 25 block diagrams by 25 block diagrams, then it's just not going to work. So this VI I got from the Ruth Goldberg machine post on the forums. You can find other gems like this, why LabVIEW gets a bad reputation. So definitely if you want to say, if you want to use LabVIEW compare with a VI that went from being a state machine into a producer-consumer, event-driven, it's not going to work. Either the program is going to crash on you, or the amount of information you're going to get is just not going to be useful. So back to Alan's comment earlier, this is to use on an hours type of deviation of work, and not necessarily let's compare what I had 2 months ago with what I have now. LabVIEW merge is LabVIEW merge exe. It's equivalent to merge VIs dialog box. It's found in tools merge VIs. How many people here have used it? Okay, about the same people that have used the LabVIEW compare. Okay, it's available only in the LabVIEW Professional Development System. And just like LabVIEW compare, it works better with small changes on small block diagrams. Again, if you're adding a new case structure, case diagram or case frame to your existing case structure, good. But if you are adding you're separating case structure that you had into 2 loops and now you have a producer-consumer, no, good luck with that. I don't think that's going to work. All right, and then my main thing here is I'm going to show you how to set up these tools. There are organizations that, because they are following the text-based style or processes, are adamant that they have to have these tools working. So I can show you how to set them up. However, I want to make sure that we have these things clear. Avoid projects where block diagrams are too big. Like that should just be something that gives you the GBs. VIs that have too many responsibilities that are not cohesive. Developers working on the same VI at the same time, even if it's on their own branches. Just avoid that. And using text merge tools onto libraries like LabVIEW, LabVIEW and LabVIEW. What's the format of those files? It's text, but what is it? It's an XML format. However, even though it's text, the build specification, for example, of a project contains binary coded information. So if you merge your projects, this is a good way of corrupting projects. It's also a good way of corrupting libraries and classes. So do not merge those files. That's why I recommend having an owner. Do modularize code, create VIs with a single responsibility, distribute developers' workloads so they are not working on the same VI, and assign owners for your LabVIEW, LabVIEW, LabVIEW files, and also do conscious commits. What I mean by this is, how many times have you made a change? And then you get like 3 dirty dots, and you're like, but but I didn't do anything, right? So when LabVIEW pops up and says, do you want to save this? It has a little link there that says what changed. So click on that. And it's going to tell you an attribute of the project change. You don't need to commit that, right? An element of the project moved. And you just know that what you did is you added something in a library and then moved it to a virtual folder within the library. What do I need to commit there? The project or the library?
Library.
The library. I don't need to, the project is getting a dirty dog just because it detected that something moved in the project. So my recommendation is you do conscious comments on what is it that I changed. I do sometimes be like, oops, you know, I've been doing too much and I really lost track of what I did. So I do the commit of the things that I'm completely conscious of what I did, and then I do another commit that I just put as a comment. I'm just saving all because LabVIEW is asking to save all. What's another thing that you can do to avoid this issue is separate source code from compiled code. Okay? If you're not doing that, LabVIEW code that ships on VI Lead now, it's all, or not all, most of it is separated source code from compiled code. All right, so how are we going to configure Git and Mercurial to use these tools? This is the following, is the syntax that we're going to be using. The arguments for compare.exe, and like I showed you, this is just from the help. I'm just getting the information you need from there. And it took me a while to realize that these things were acronyms, right? So NOATTR means do not compare VI attributes. NoFP means do not compare from panels. NoFP position, do not compare size or position of from panel objects. NoBD, do not compare block diagrams. NoBD cosmetic, do not compare the appearance of block diagrams, etc. And merge has a very similar approach too. Now, with merge, you have an optional first argument that if you want to specify which LabVIEW version you're using. If you don't specify it, it will just use the latest one that you're using. Then you have an absolute path to the base VI, to their VI, your VI. I always get asked, Fabiola, how do you know which one is the VI? Like, you know, you are dealing with conflicts, you know the VI you were working on. So when they show up, I'll figure out which one is base and which one is yours, and I don't try to get too dragged down into that. All right, so let me show you how we do the setup. Okay, so on this one, we are going to go to Tortoise Kit, and I'm going to go to Settings. And then on the Settings, I go directly to the Div Viewer, and on the Div Viewer, I'm going to go to Advanced, and this is very similar to Tortoise SVN if you've seen it. Then we're going to add here for .vi. So the external program we're going to be using is from Program Files, National Instruments, Share, LabVIEW Compare, LVCompare.exe. And I'm going to put all these videos are going to be available for you to see. And then I'm just doing the same arguments, no block diagram, cosmetic, and no position. So I'm doing it for VI, for CTL, for CTT, and for VIT. So what is CTT? Control template. And VIT?
VI template.
VI template. So those are the only files that I can use with compare and merge. All right? So no BD cos means do not compare block diagram cosmetic changes. And then no BD pause means do not compare size or position of block diagram objects. So this is one of the things when you're working on an organization, you're going to make sure that they're not doing diffs on that because pixel by pixel. And then the same thing is going to be done for merge. In this case, we went to the merge settings, and we're going to do the same thing for VI, for VIT, for CTL, for CTT. And the difference on the arguments is that we are going to set the percentage base, percentage theirs, percentage mine. LabVIEW does tell you what each one of those percentages things mean when you're hovering over that line. So you don't have to remember this. All right, questions about that? No? Okay. So the reason we chose to do it with Tortoise Git and not source tree was that Tortoise Git makes it really easy to configure. You just go to that Git viewer, right click, you're set. You don't have to do any command line configuring. If you are using source tree, I believe you have to go into a little bit more pains to get it configured. All right, so on the next one. Okay, so now we already have everything configured, and what I'm going to do is go to the project, and and we're going to make a small change. So I go to my main BI, it's a state machine, and on that state machine, we're just changing the do something to say show hello world. So we're just changing the button text there, and that's all we're going to do. And now I can right click, go to Tortoise Kit, and click diff. Because I configured it in the previous video, Git knew to call LabVIEW compare. So opens the LabVIEW compare that we already all know and love, and I show on the left I have the new version, and then on the right I have the version of the repository. So if you wanted that backwards, then you just have to configure the percentage mine base and all that in different order. All right? Questions about that? It's not complex, right? Okay. So the next one is the Git commit. So how are we going to be using the Git commit? Okay. So on this one, I just right click, go to Git commit, and it's committing to my master branch. I put my comments, I change the Boolean text, and then I just click on the commit. And the commit right now is just committing it, and then once I'm done, I do the push, and we're done. Okay, so the next one. Okay. They're not blurred, right? LabVIEW merge with Git. So now we're going to do the same thing, but this time we're going to go to settings. Oh no, first we're creating a branch, naming it feature 1. So we're going to do the thing about using branches here. And I am going to say that I want to switch checkout to that feature 1 branch that I just created. So I then go close, and I am going to open my main BI. So my main BI has there the show hello world, and we are going to we're going to replace the user state to be doing the code for show hello world, and we're going to save. We're going to commit to feature 1. The Git commit says Git commit to feature 1. So this is a specific name branch, where what we were seeing earlier was always on the same branch, but different developers working on the same branch. We commit, and then what we're going to do is I'm going to go back to the master branch. So I go and do the switch again, but this time I'm saying I'm going to go to the master. So if I open the master is not going to have that code of the show hello world, right? Because that was done in feature 1. So if I open, I do have the text on the button, but if I go to the user state, there's no show hello world there. But what we're going to do here is I'm going to add, in the master branch, I am going to add there a timeout. So I'm going to do that. And this is why it's important also to set up rules on your teams. Like maybe this should have been in a different feature, right? Maybe this should have been feature 2. So we're adding the wait for event there. And then save. And we are going to commit. Right, so. And this time I'm committing to master. So master has adding a timeout event case where feature 1 has the code to say hello world, right? Now we're done, and Tortoise Kit merge. So what I'm going to do now is I'm going to go to Tortoise Kit, and I am going to tell it that I want to merge branches. But now I know that both branches touch the same BI. So I'm going to merge the current branch master with the feature 1. And you can see that it says Git did not exit cleanly. I have to resolve my conflicts. So I have a big flag there that says that I have a conflict, and I can now go to Tortoise Kit and say that I want to edit conflicts. You can see that it created a main BI with base, local, and different. It basically renamed the different versions of the BI, and it opened and launched LabVIEW merge for me. So if you have used LabVIEW merge, what it does is it lists all the unresolved conflicts for you, and it lets you choose between the 2 versions that you have on your lab, which one you're going to be using. A text merging tool would do the same, right? It will show you what are the rows that are the same, and it will show them to you side by side, and you can choose what is it that you're keeping from each one of them. LabVIEW, because it's graphical, is going to be showing even differences like which one is the visible case. So in this case, it's showing that that's a difference between the 2. And then what you do is you can choose which one is the code that you want to keep on the final version. Now, because of all these extra work, this is why I suggest to avoid having to do this in the first place. I think maybe I've done LabVIEW compare or LabVIEW merge maybe a handful of times. Normally, one thing that I'd also like to say is that having good tools does not avoid or prevent you from talking to your team. And sometimes it's just a lot easier to pick up the phone or walk to their desk and ask them, what did you do here, right? Is it really worth the time investment to do a LabVIEW merge? Or do I do a take mine or take theirs and then have one of the two redo the work that they had done? Like if they put in a label or whatever. And that is going to be the pain that you're willing to put up with is going to be team specific.
Bookmarks are fabulous for resolving those sorts of conflicts.
Oh yeah, bookmarks. Yeah, that's a good point. Bookmarks are really good for resolving conflicts. If you are having to, like, it might be that you know, this happens a lot to us where we have people working all over the world. So if I'm working with a team in Australia, they might be asleep, right? So I know that they're working on that BI and I should not be touching that BI, but I really need to do that. So for whatever it is that I'm doing, so I'm going to leave a bookmark and I'm going to leave a big commit that says, sorry, I really had to touch it. You can find all my changes by looking for this bookmark. And then they can decide if they do a merge, if they take a peek, like I showed you earlier, to see what is it that I did. And then they can choose whether they use the tool or they manually do the merging. All right.
Fabiola?
Yes?
I noticed in all of these videos you're initiating source control commands from the operating system, File Explorer. Do you have any thoughts or experience on trying to do it natively from the LabVIEW?
LabVIEW, there are several tools out there that either break with new releases of LabVIEW, that I have not found one that I can stick with for the long run, so that's why I use it directly from the File Explorer. But if you're interested in that, there's two user groups at ni.com. One is NHE and the other one is on Git. And there are talks there about different tools that people have put together, and some of them are open source. So if you want to collaborate with them, I'm sure you'll find the way to do it.
That's not something that you normally do.
No, I found, this happened to me also. Viewpoint has a really good tool for Tortoise SVN, but I found myself always going back to the Windows Explorer. And the reason for that is I like to go to the top level folder and do a right-click commit, and it shows me a picture of everything, any files that I added, autoplays, anything that changed. So that's why I like to do it that way. But again, it's just, it's a preference thing. There's definitely tools out there. The Viewpoint Tortoise SVN, I trust that tool. The ones for HG and Git, I haven't found one that works for the long run. I know that Viewpoint is working on something, but I have no idea when they're going to come out with it. All right, edit HG global settings to configure LabVIEW merge. Notice that I'm not saying how to configure LabVIEW compare for Mercurial. This is one of those where you need to do a wrapper for LabVIEW compare, because LabVIEW compare, the whole thing with the command line, the CLI, doesn't work when you're trying to hook it to the existing tools. The wrapper is out available on GitHub, but again, it broke when we changed from one version to another version of LabVIEW, or it broke when there was a new version of Tortoise HG. So I'll have the point on where to get it, but that's why I'm not showing you how to. It is possible, it does require a little bit extra work. So what you have to do is you just find your settings, and on your global settings, you're going to set this. Now, the code and the examples that you find online, they are listing that they are changing also, or listing as merge patterns, LB Proj, LB Leave, LB Class. As we mentioned earlier, that's completely useless because we don't have a tool for that, and LabVIEW merge is not able to do that. So that's why I didn't put it on the video. So on the video here, we configure LabVIEW merge for Mercurial. And then we go to the global settings, and I'm using Tortoise HG. And I go to edit file, and I just make sure that I add that. And that's all you have to do it. Okay. So the next one is basically showing the same thing that we did with Git, but it will be showing it with Mercurial. Like I said, I'm going to give you all these videos so you can go and produce it at your own leisure. It's the same set of steps. We create a new branch. The only difference is that on Git, the main branch is called master, and on Mercurial it's called default. We go through the same steps. I wanted to make sure that I have room for questions. So the final discussion and next steps. Distributed source code control does not require a connection to a central repository at all times. That is mainly the biggest difference. Every team member has a complete copy of the repository, including the entire metadata. That's why they're able to see all the history of commits and comments and stuff like that. That's also why, for those of you who use TestStand, please make sure that you're not including your source folder into your TestStand deployment. I see the face here. Because we were in the middle of New Zealand once, and we couldn't figure out why our download was a terabyte big. So it turns out that when the TestStand files were dragged in, they were dragged in with the HG hooks in them. So we were not taking only the current version, but every single version available of the VIAs. It's still advisable to have backups of the repository, but they are not as crucial as with centralized source code control, because of what I said earlier. Avoid working on the same VI on different branches. And overuse of LabVIEW compare and LabVIEW merge is a symptom of an architecture that is not modular enough. Or maybe is a symptom of a process that has multiple developers working on the same code at the same time. If anytime I hear someone saying, I absolutely need to have this, my question is why? Like, yeah, I can show you how to do it, but let's go back at, do we have a bigger problem here? You should be only dealing with this very rarely, right? Even on DQMH modules that have so many files and you have the centralized one, we don't have everybody working on the same code. Oh, there's the wrong one. So some references, I have a blog post on the developer.com blog. Every developer needs a time machine, and that's just basically an introduction to source code control. That one shows some of the setup that I showed up here for SVN. So if you're trying to decide which version you want to go to, you can see the 3 videos. The videos that I just showed as demos, I uploaded yesterday to bit.ly/lvscc, and I'm going to be posting shortly, because I did this presentation for Dev Days. I had to wait until all Dev Days happened. So I'm going to post a new blog post on more specifically this discussion about merge and compare. There's a very good Atlassian tutorial for Git. It can also be applied for Mercurial. And like I said earlier, there's a Git user group and a Mercurial user group if you want to find out more about development of tools that work natively on the project.
So I've used both of these, and of course, ones that are centralized. And but I just wondered, from your perspective, did you have an opinion of which one you liked better, and if so, why?
So the question was if I have an opinion. I always have an opinion. Which one works better, and if so, why? My experience is if you have a team of developers, subversion tends to get in the way of forward progress more than the distributed or perforce. Anything that's centralized tends to get more on the path of forward progress. If you're a single developer, you don't need to do this. Subversion, perforce, any centralized would work, but you really, even if your applications are small, once you go source code control, I think you're never coming back. So
SVN.
yeah, so you can do SVN, and then you use the Tortoise SVN. But that would be my answer. Teams go distributed. Single developer, they can do whatever they want. Now, as far as choosing between Mercurial and Git, from the training perspective and helping teams to get up that learning curve, Git is a lot more used out there, and there's a lot more references, but it's also very powerful. And you can do things like switch back and forward and roll back commits and tons of things that I'm getting people that were not using source code control, and all of a sudden I told all this to them, that just doesn't work. Or they're coming from SVN. It's a lot easier to get people up to speed with Tortoise HG, with Mercurial, than it is to get them up to speed with Git. That's my personal experience. It could also be that I'm not that good of a teacher on Git as I am with Mercurial, but that has been my experience. And does that answer your question?
So I will add one comment. You talked about how, you know, you had that terabyte size download because of the test band source code control. When you are configuring your projects, please do not put your builds, especially your installer builds, into the location that they're going to be picked up for addition by source code, because then again you get into the, oh, let's add 1.5 gigabytes
Yes.
of data into my source code repository.
So ours comment is not put your EXEs and your installers on the same repository. This is more of an issue with distributed, because in distributed you have to clone the entire thing. So if you are in a remote location, now you have to wait until you download everything. Now, the counterpoint to that I've also gotten from people is, especially like consultants that might be working with 15 different companies, and there's a company that calls every 5 years. Having a different location for builds and installers means that when you're getting back to work with that person, you might have a harder time finding all that collateral. So that's the argument that some people use to have a dependencies folder that includes all the drivers that you need and all the installers. It's a toss-up. You just need to decide which way you're going to go and make sure that you document it clearly. It is an advantage. What we do at Delacorp is we do a virtual machine better. That way, I have my archive virtual machine. When the customer comes after 5 years, I check out my virtual machine. It has the drivers as I left them. It has the LabVIEW version they were using. It has the executable that I distributed, etc. We also use we use BIPM for keeping track of release packages, and we use BLT, Build, License, and Track from StudioBots for distributing executables. And that means that we have a separate repository that only has the executables and what were the versions that were pushed to specific customers. That also gives the tracking, so I can know when they ran it, when was the last time they ran it. It does licensing, and it also does a beautiful feature that's error reporting. Because how many times do you get a call, I got an error, and what did it say? I got an error, right? So the error reporting actually gives you all the values and the state of the front panel, at what time it happened, and depending on what information you're putting in the front panel, you might be able to recreate the steps that got them there. Any other questions? Well, I hope you found this useful, and if you have any more questions about this or anything that has to do with team development, I'll be around. And like I said earlier, I don't know who's presenting, but there's going to be a choosing your framework, and they're going to be talking a little bit about the QMH.
That last tool for distributing executables, does that work for real-time executables, or is it database?
I think you can contact StudioBots and ask them. I have not used it for real time, so I wouldn't know to tell you, but I know for sure that it works for EXEs. Anything else? No? Thank you very much.